Hi, I'm Neil, and I'm going to give a brief introduction to our paper, Lorentzian Residual Neural Networks, accepted to KDD 2025. Our paper concerns with deep learning in hyperbolic spaces. The Euclidean space, which is a form of geometry that we're all familiar with, are flat spaces and have uniform scaling. On the other hand, in hyperbolic spaces, which are Riemannian manifolds of constant negative curvature, volume grows exponentially with respect to distance. All the fissures in this picture are actually of the same size. So in a sense, there's more room for us to place objects in hyperbolic spaces when compared to Euclidean spaces, as we move farther away from the origin. This means that hyperbolic geometry is particularly suitable for embedding hierarchical structures, such as a tree where the number of child nodes grow exponentially at each level, or in images where there's a whole versus fragmentation hierarchy. This motivates using hyperbolic spaces as the embedding space for deep learning on hierarchical data, for which we need a way to perform residual connections. The difficulty in designing hyperbolic residual connections is that we cannot simply add vectors like we usually do for the Euclidean space, since the sum of two hyperbolic vectors don't necessarily live on the manifold and might violate geometric constraints. So we need a geometric operation. Previous methods typically map between the manifold and tangent spaces, resulting in many issues, including numerical instability, runtime inefficiency, mapping errors, lack of geometric meaning, and non-commutativity, just to name a few. To alleviate these limitations, we propose a method that is a weighted sum of hyperbolic vectors with specially designed weights. It is simple and computationally efficient, and has theoretically guaranteed numerical stability and generalizes previous methods. We also conduct extensive experiments to show that LRSNet is effective and robust when integrated into many hyperbolic neural networks, including hyperbolic GCNs, hyperbolic graph transformers, and hyperbolic CNNs. So yeah, thank you for watching, and please talk to us and read our paper to learn more about details.